homework done? Well, I don't want to say that because some of y'all probably didn't. Were there any questions on the homework? Pretty simple, huh? Just make a little dot plot and then just describe it. Okay. Let's talk about the bell work real quick. On the bell work, let's talk about this first one. What did you guys call this first one? Uniform. What else could I have called it? Symmetric. So this was a symmetric uniform distribution. Okay, just because of symmetry. What about this one here, number 2? That is a left skew. Okay? Please remember, it's where the tail is at. Okay? So this is called the left skew. Okay? It's where the tail is going to be at. Can you say that this is symmetric? No. How about 3? What is 3 called? Bimodal. Because it's got 2 numbers that happen the most, and that is also symmetric in this case. Well, somewhat. Right? Okay. So if there's no questions on the homework, let's go to the next part. Yeah, always have your bell work turned in. Just wait right now if you're holding on to it. But as soon as you get it done and I start, that should already be in there. You got like 5 minutes most by the time I get done with the bell work, okay? Slideshow from the beginning. All right, cool. So we already talked about how to describe distributions, but we need a little bit more, right? I mean, when we talk about it, we're a little bit vague. Oh, it looks like the middle is right about here somewhere. It looks like the center could be here, it could be there. It looks like the range is this, blah, 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 that good stuff. But sometimes that's just not enough, okay? Sometimes you're going to need some numbers that actually kind of tell you exactly where the middle is or exactly what the spread is and stuff like that, okay? Do you need paper red? Okay. So, here's some sample data. And let's consider these test scores. Now, every time you get data, you guys remember, right? Are we supposed to have them in this order like this? No, they're all mixed up, right? The first thing we should do is to put them in order from the least to the greatest, so that ascending order. Whoa, I guess that's all I wanted to do. So let's put these in order real quick. Let's put these in order. What's the smallest value up here? 74?
45.
Oh yeah, I didn't even see that. I need another pair of glasses on my glasses. So 45,
68,
68,
74,
watch out,
82, 76, or 5.
75 and then 76. All right, cool. So we got that one, that one, that one. Oh, okay, we got that one. Where are we at?
82.
There's 2 82s? 1, 2, so 82, 82, 91 and then 98.
93.
Ah, man. You guys know if I take my glasses off, I can't see squat. Like I could see, but everything looks like a big old. Bleh. Yeah, that's embarrassing. That's embarrassing. You know how you ever do the eye chart? The eye chart and that's what the letters are? And they take my glasses off and I was like, all right, what's that letter on the top? I'm like, that's a letter? It's a circle. A big old round thing. I was just blind. The doctor's like 500 over 20. Because that's as far as I can check. I'm like, put my head down. But anyways, here's the data. It's in order. That's what we want to do. We want to be able to talk about all this good stuff. So let's talk about center real quick. Center, it's going to be the middle of one, right? So let's see here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data. Now, what's going to be, obviously there's not going to be one number right in the middle, right? Because it's even. When it's even, we're going to get 1, 2, 3, 4. It's going to be those two that are in the middle. Okay, so in this case, 2 numbers in the middle. If I want to find the actual center, then you guys remember what I have to do with those 2 numbers? What am I doing? I'm going to find the average of them, huh? So I'm going to add them up, divide by 2, so I don't have to talk about all that good stuff. Now, as far as spread is concerned, did this not write my 8? I would say, in this case, it looks like numbers go from 45 to 98. Or I can also say, what's 98 minus 45? 53. The numbers range 53 units wide. Okay? Did I do that wrong? Oh. It's because they don't like me. I bang on the smartboard too much. So anyways, let's talk about a couple measures of center. The first one is this thing called the mean. Okay? And I think the other name you guys have heard for it is the average. You guys have heard the average, right? Well, when we're talking about statistics, we're talking about the mean. And it's the same thing. Okay? It's the same thing. You guys remember the formula for mean? Here it is. What? Yes. This is a formula for me. It's the condensed form. It's a short version. Now, don't let it scare you. And I actually don't even write it like that myself. I just write it as this. Okay? Because we know that if you multiply 1 by the whole number, you're just going to get that whole number, and you're going to divide by a fraction. So, I want you to notice this symbol as well. You guys see that? It's an X with a bar on top of it. You know what that's called? X bar. Shut up. Yeah, it's called X bar. That's the name of it, X bar. So whenever you see X bar, that means they're giving you the average or you're writing the average, okay? Now this is the way that's the formula for it. Now don't let it scare you like I said, okay? That big E looking thing, this guy, that is a Greek letter sigma. It's an S. It's a Greek letter sigma. And it just means add all these things up. Add them all up. So what are you going to be adding up? All of the x of I. You guys remember we said the individuals, x of 1, x of 2, x of 3? So in this case, we just call them x of I because I can change, it can be whatever you want it to be. So it's just saying, add up all your numbers and divide by the size of the sample, or how many numbers you got. Isn't that exactly what the formula is for average? So it just looks fancier. Make you feel like math magician over here. But that's the same formula. I want you to use that, get used to seeing that sigma. It's not going to be the first time you see it. You're also going to see it when you get into pre-calculus and into calculus, when you're doing your Riemann sums. But don't call that an E. That's a S, and it means add these things up. Understand that? So, simple enough? I think you guys have probably seen, let me see here. I think I got the old version of it. But this is what it's telling you to do. What? It's the same one. But this one's easier, it's cleaner. Okay, this is supposed to be for x bar. This is just saying, take all the x's, add them up, and divide by how many of them you got. Simple enough? Any questions? All right, cool. Moving on. You look confused.
Wait, did you explain what the bar on top of the x meant again?
It means that symbol itself means it's the mean, it's the average. Okay? That symbol's called x bar. If it's just an x by itself, then what is it? It's a raw data, isn't it? Okay? It's just, a datum. Okay? When I have them all together, that's my data. And when I'm looking for x bar, that's just telling me, hey, this is the average of the x's. Okay? And that's really what it means. Once you put a bar above it, it's saying it's the average of the x's. Okay? If I gave you something that said y bar, then what is that? Average of the y's, if I did have y's. Okay, but in this case, I've got x's, don't I? So it's the average of the x's, or I could be talking about the average of the y's. If I wanted to call them p's, I would call them p bar, whatever it is. But that bar on top means, hey, this number represents an average, or a mean. Okay, mean is the word we use the most in statistics. I want to get rid of this because then I forget to not save. And then it's stuck on there. Okay, any questions on the formula? Simple enough? So, these are all names that you guys have probably heard before. The mean is the average or the arithmetical mean. I don't ever say the arithmetical mean. Okay, many times I don't even say the mean by itself. I'll just say, hey, the average, because we've been using it for a long time. Like 9 years, right? No? I never used it. I don't know what you're talking about. All right, cool. Anyways, there's other ways of doing it. When you put your data in order from least to greatest, and you find the number that's right in the middle, we call that bad boy the median, because like right in the middle. Just like when you're driving down the street, right? What's the name of that dashed line? Shay? If you're driving on the road, there's a big dotted line in the middle, huh? You know what that's called? It's called the median. Why? Exactly. So same idea here. When we've got our numbers and we order them and we put them from least to greatest and we're looking for the number right in the middle, we're going to call that number the median. Okay? So the nice thing is, I like it when it's odd numbers because then you don't have to worry about which one it is. There's just one number right in the middle. But if it is even, just like in the first data set, you're going to have to add those two numbers and take the mean of those or the average of them. Okay? Questions on this slide? Stuff you guys already know, right? Easy. Okay. Now, what's the difference between those? What is the difference between them? They're both measures of center, right? What do you got?
The mean is the, like the, I don't even know how to explain it. The mean's the average of the data, and then the median is the middle number.
Okay. Something simple to understand, or the biggest difference that I want you to know. That was good. The biggest difference that I want you to know is this right here, what's in bold, okay? This bad boy, very important. The mean is not resistant to outliers. What do I mean by that? Well, let me show you this real quick. No, discard the annotations. So let me show you what I mean. Let's grab a small data set, okay? Something like 1, 2, 3, 4, 5. Okay? Simple enough, right? Let's find the mean of that. That means I would have to go 1 plus 2 plus 3 plus 4 plus 5, divide by 5. Guess what I would get? I would get 3, wouldn't I? Okay? Now, if I wanted to find the median, and if you guys don't know what the symbol is, it's just a capital M. Okay? Now, to find the median here, what is it? It's the one in the middle, which obviously is 3. So that's beautiful. Now, here's something very important to know as well. If your distribution is symmetric, then your mean and your median are going to be the same. Okay? If your distribution is symmetric, okay, then the middles will always be the same for both mean and the median. Now, we're not talking about that though, are we? We're talking about how outliers affect the average. Let's put another number up here. Let's put 6. Seems like it's okay, right? Okay. What's our average going to be? 3.5. What's our median going to be? 3.5. Now, if we do that, everything's hunky-dory, everything's fine, right? We're like, okay, cool, whatever. Let's throw an outlier in there. An outlier is a number that's just like, that don't even belong there. Like, where did this come from, right? So what's the number that I could put up here if I'm going 1, 2, 3, 4, 5, 6, and then I just say, you know, some funky number. What? Is 9 really bad?
17.
18.
Let's make it drastic. Like, what'd you say? 18, 17? Who? Yeah, let's go with 18, okay? Now, here's what I want you to take a look here, okay? So let's take a look at what our new median is. I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. That means that my median is now 4. Was that really affected? Like, did it really have an effect on my middle number? No, it didn't, right? It kind of made sense. But let's take the average of this now, okay? I'm going to use a calculator. I don't know about you guys. Here's my expectation. When you guys come into class, calculator's right there. Grab one on your way in. But I'm going to do this. You already added them up?
139.
Awesome. Ah. So 18 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 39. And we're dividing by how many? 7? Divided by 7, right? So 5.57. That's almost 6, isn't it? Was it affected a lot? It was affected some. I mean, that's a big jump, isn't it? This kind of jumped half a point. How much did this jump? This about, yeah, about 2.5 almost, huh? But let's make it, who said 100? Let's change this number to 100 and see how that changes it. Okay, so here's my 100. Does that even affect my median over here? If I went from 17 to 100? No, it would still be 4. So instead of the 17, was it? Let's go with 18. So what do we got? Let's see here. How much is it? 121? You're awesome. 121 divided by 7. Check it out. 1728. Was that a big jump?
Yeah.
Okay, so this is really, really drastic, but it's important to know that when you're trying to work with a mean, and if you got outliers in there, then you're going to get something that is not representative. Would you say 17.28 is kind of representative of that data set? Would you say, oh, it looks like it should be in there? Not really. And who did it? There was that 100 number in there, right? Does that make sense to everybody? What I'm trying to say there? All right, cool. Let's move on. right, cool. So we got that. So those are two measures of center. Those are the two main ones that we use the most. We use the mean and we use the median. Now let's talk about measures of spread. How the numbers are spread out. Okay? So let's see here. Here's my list. Okay? Range. This one kills me because I don't know about you, but I remember they like from almost kindergarten all the way to like 8th grade. Find the range, find the range, find the range. Well, the range is meaningless. Think about the other data set. What were the numbers from? It was 1 to 100, wasn't it? Can I really say that my data set ranged from, it was 100 digits wide? That doesn't even make sense, does it? Like, dude, it really just went from 1 to 6. You had 100 in there, but it was really just under 10. So, range is not really that accurate. I mean, unless your data set kind of lends itself to that, then you're good. But we don't really use that a lot. Now, what we do use is this quartiles, okay? And what we use is this thing called the IQR. And I'm going to show you guys how to do that in a little bit, okay? So we'll be doing the IQR, and we'll be doing variance and standard deviation, okay? So those are the two main ones. This is probably the biggest one, standard deviation, and then we'll be doing IQR as well. So, and I'll show you guys how to do those. Standard deviation you probably won't do by hand, because that's a yeah. I could show you, but you probably tune me out after like 2 minutes or so. You won't want to be doing that anymore. So, questions on those two? Okay, cool. And of course, you're gonna want to choose what's most appropriate. If you have outliers in there, here's gonna be my recommendation to you: is to use the IQR. And IQR simply stands for interquartile range. Okay, so if you got outliers that you know they're going to be affected, use the IQR. If your data seems pretty decent, pretty normal, then standard deviation, the standard deviation would be good. I want you to make the note of this as well. If you have outliers, you're going to want to use the median for a measure of center, and for a measure of spread, the IQR. Those two are married, man. They always go together. The other thing is if you have data doesn't have that much outliers in it, you're gonna want to use the mean, which is X bar, and the letter we use for standard deviation is S. Those two are married as well. Okay, so it's gonna be one set of values or it's gonna be the other set. Okay, do not mix the median and talk about standard deviation. It's not gonna be very useful. Okay, it's either this set or it's gonna be this set. Questions on that? What's up?
I don't really remember how to do the range.
Range? Big number minus a small number. That's all it is.
And the other one, the IQ.
I'll show you those. I'll teach them to you. But yeah, if you want to do range, like remember how the first set, remember how I took the big number, what was it, like 90? I'm lying now, I don't even know. Right here, yeah, it was 98. So 98 was the biggest number, wasn't it, in the data set? And the smallest number was 45? So if you do this, you take the biggest, took away the smallest, that's going to give you the range. So in this case, it would be 53. Okay, so it's 53 digits wide. Okay, so moving on up. Okay, quartiles. Now, obviously, if we're going to get an interquartile range, we need quartiles, don't we? Now, what is a quartile? Sound like another word you know? Quarts, quarter, quarter. Everybody know the word quarter, right? Anybody know why a quarter is called a quarter? Because it's a fourth of a dollar. It's a quarter of a dollar. So same idea here. When we're talking about using quartiles, here's what you're going to do first. You're going to order the data from smallest to biggest, which you guys already know, right? Do I really need to go in detail here? What you're going to first do is determine the middle of that. So let's say you've got numbers that go from here all the way to numbers that go from here to here. Then the first thing you want to do is find the middle. Okay, that bad boy's called the median. Correct? What's this guy called then? Do you guys remember? Quartile? Any ideas? The minimum? Because it's the smallest number. A lot of people want to call this the first quartile. But do you have any quarters in there yet? No, so you can't call that quartile 1. So anyways, so there's a median, and then what's this bad boy called? That's the max, okay? So I got 2 halves here. How do I get quarters? Cut the halves in halves, don't I? So half here, half here. This one is called quartile 1, because that's the first quarter you've reached. Another name for this bad boy is quartile 2, but we like to call it the median. Over here, this would be quartile 3, and of course the max would also be just called quartile 4. So there's your first quarter, second quarter, third quarter, and then your fourth quarter. Okay? Questions on quartiles? All right, cool. So we've got the median. We already did the first quartile. We did the third quartile. Those are going to be the important ones when we're trying to find the interquartile range. Okay, so here's an example. Let me get rid of this right here. Okay, so here's my data set. The first thing I need to do is to find the median, the middle, right? So, bam, it's right there, it's 26. Then I'm going to find the middle of the bottom half, which is right between 23 and 23, which happens to be 23. And then I'm going to find the middle of the top half, okay, which happens to be 29.5. Why? There's 2 numbers in the middle, so I'm going to take the average of those 2. Okay. Now here's the way it works, because some people kind of get confused. Once I pick the median, if that's actual median, don't even consider it anymore. Okay, 1, 2, 3, 4, 5, 6. See that? Got 6 on one side, 6 on the other side. At this point, then I can find the middle, which would be these 2, and of course that gives me that average. Over here I've got these 2, that gives me this average. Questions on that? Okay. Here's another data set. What's the difference between the 2? One's odd, one's even. This top one was an odd set. The bottom one's going to be an even set. Okay, for some notes. You got it? Okay. All right, so here's some paper for some notes. Here's the even data set, okay? If it's going to be an even data set, I'm going to get 2 numbers in there, aren't I? Okay? So I'm going to get, and I just kind of jumped it, but notice how the median is not either one of those 2, is it? The median is in here somewhere. That splits up my quartiles to be 5 and 5. Do you see how different that was from here? Do I ignore these 2 middle ones? No. Okay? So I got 1, 2, 3, 4, 5. That's my quartile 3. That's my quartile 1. Questions on that? Okay. Now, the IQR, the interquartile range. Okay, that's where the middle 50% of the data is. How do I find that? Here's your formula. It's fairly simple, actually. If it's the interquartile range, aren't these 2 the inside quartiles? The 2 middle ones, aren't those the inner quartiles? So I'm looking at here and here. So what you're going to do is you're going to take Q3 and subtract from that Q1. Very much like a range, isn't it? Okay, but because there's outliers, do I really care about the edges? No, I want that middle bulk of the data. So what I would do is take 29.5 and subtract from that 23. So that means that my IQR is 6.5. Questions there? Simple enough? What's the IQR for the bottom set? I got 17. Can somebody confirm that? I did it in my head, so I could have made a mistake. Yeah, thank you. All Alright, moving on. Okay. I like this question. Everyone knows a little bit about baseball, right? Everybody's heard these two names, Barry Bonds and Hank Aaron. And the question is, who is the better ball player, right? Who was the better ball player? Well, Barry Bonds had an average of 35.4 home runs per season. Hank Aaron only had 34.9. So who was the better ball player? Barry Bonds, huh? Would you agree with that? Yeah? I don't think Julian would agree with you. Julian, why? It's opinion.
I'm just going. Yeah,
It's opinion, right?
Yeah,
I mean,
if you're going off of this, but if you're counting like their averages of home runs and then you count their averages of, what do you say it? I don't know how to say it.
was it the RBIs and stuff,
Yeah.
and all, and the hits, and the at bats, because that matters too, doesn't it? How many times were you at bat? Did you hit every time, or were you at bat more often, so you got more chances to hit the ball? So there's a bunch of things we could talk about, but with this alone, I could convince you, couldn't I, that Barry Bonds was the better player? Obviously. Now, we could sit there, we can calculate the average. You guys are gonna be bored as heck. We're gonna take all these numbers, we're gonna add them up, divide by how many there was. Boom, I'm gonna get 35.4. Over here, I'm gonna get 34.9. You guys know how to do those two, so I'm not gonna waste your time, bore you with that. But here's what I want to do. I want to be able to for you to calculate what an outlier is. You understand that? Like, does this really belong with the data set type thing? Because sometimes you get those good days, huh? I'm on fire, and they're like, man, and then that's all you do, huh? Man, I scored 20 points at the games, man. That's how I roll. Man, dude, you only score 4 or 5 every time we play. You're probably just on fire or something, right? So what I want you to be able to do is to figure out whether this data set has an outlier or not. Okay? Cool beans. So we need this information in order to do it. We need the IQR. So let me show you how this is done. You guys ready? And here's the formula. It's 1.5 multiplied by the IQR. So you're going to take the IQR and you're going to multiply by 1.5. That's going to give you a number. Okay? And I'm going to show you what you're going to do with that number. Okay? So here's what I want to do real quick. I'm going to set up 2 box plots. You guys remember box and whiskers stuff? For Barry Bonds, BB right here. His min is 25. Then we have the median go to, I'm just going to do it like this. Is that cool? So the median is 34. His quartile 1 is 25. Whoa, wait a minute. Where's my min? Oh, I'm going to have to get it from the other page, huh? All right, let me do that real quick. So I got quartile 1. I got quartile 2. This is 25 right here. 34 right here. 41 right here. Now, can everybody confirm that the IQR is 16? 41 minus 25, right? I'm cool with that? So I want to grab the min real quick. What was the smallest number? 16. And the biggest was 73. So 16 and 73. Now, Hank Aaron's. I'll do something very similar to that. Okay. I'm going to do his box plot. He's going to have a 28 here in quartile 1. His middle is 38. Got a 44 over here. Let's see here. What was his min? 13 and then 47. So 13 and 47. Okay. So everybody understands how I did those box plots? Nothing new here, is it? Okay. The only thing I want to know is, are there any outliers in here? Why would an outlier be important to us?
Because it can change the,
What can it change?
it can change the average.
It could change the average, huh? Make it look good. Here's what a lot of people say. Take a look at this. See how it went 13? I mean, these are kind of spread out, but they all seem to be together, don't they? Take a look at Barry Bonds' data. Is there a number that seems out of place in here?
73.
That's 73, huh? I mean, he would go 16 to 46, but all of a sudden he's got a 73 in there. So does that really affect him? Now the question is that even an outlier? Can I even say, oh, there's some shenanigans going on? Okay, we don't know. So what we're going to do is we're going to figure that out real quick. Okay, And I gave you the formula, which was 1.5 times IQR. So let's take a look. So 1.5 times the IQR. Do I have a? I want to change the color. 43.
That makes
That's
no sense.
47.
47. Why did it become what?
You wrote.
Thank you. That doesn't make sense. Because I wrote 43. Watch me do it again. Okay, no. You ever do that? You try to fix something, you write it again. Like, oh shoot. Is this the color? Yeah. Cool. All right. So let's start with Hank Aaron's. Okay. I already got his IQR, which is 16. I just need to multiply it by 1.5, which means I need to add half of this to that number. Does that make sense? So half of 16 is 8. 8 plus 16, that'll be 24. Okay, so I'm going to get this number 24. Here's what you do. To figure out if there's any outliers, from this top part right here, from quartile 3, I'm going to go 24 more in this direction. So 44 plus 24 gives me 68. 68 would be out here, wouldn't it? So is there any outliers on this side? No, because everything's inside of this little fence, huh? Okay, now let's go over here to quartile 1. I'm going to go 24 units in that direction. So what's 28 minus 24? 4, isn't it? So this number would go all the way down here to 4. Are there any outliers on this side? No, so Hank Aaron's data is legit. That is some good data. We can make decisions off of that if we wanted to. Now let's take a look at Barry Bonds. Barry Bonds' IQR, we also got 24 there, don't we? Because if I did that whole bit, it would be 24. So let's go 25 minus 24. That puts me at 1. Any outliers on this side? Were we expecting any outliers on that side? No. Let's go 41 plus 24. So 41 plus 24, that gives me 65. Oh, snap. That's in here somewhere, isn't it? You see how there's some numbers outside of that fence? Whatever numbers are bigger than 65, you could say, you know what? Those are not typical of what you can do. I would consider that an outlier. So how many numbers did Barry Bonds have as an outlier? Yeah, he only had 1. So this game was not typical of him. So when he scored 73, what happened? You guys remember? You guys remember in history what happened when he got that 73 runs on a investigation? What did he get investigated for? Steroids. What did they find? Using. Okay? He was using. Because that's not typical of what you can do. Okay? So that's how we know. We don't want to be lied to. We can take a look at the numbers. The numbers are never going to lie. So that's the way you can take a look at if you got outliers or not, okay? So everyone understand what the IQR is? IQR is simply this number. And if I want to find outliers, I got to do this 1.5 IQR. Go that way, go this way. Whatever's outside of those fences, you consider that an outlier. Questions here? Here's how I find outliers. I take 1.5 of the IQR. Okay? So if you take 16 and you multiply it by 1.5, that gives you 24. Does that make sense, Trinity? Okay? So you might want to make a note. Thank you. Move on. So we did the outliers. We're good. Okay, so there's the rule. If you guys want to write it down, that's exactly how you do it. First, get your 5-number summary, which is what we did. Determine the IQR. Multiply by 1.5, because that's going to give you a number, isn't it? Then you're going to set up those fences. Set up those fences by adding that number to quartile 3, and then subtracting it to quartile 1. Okay? Now, let me go ahead and stop you right now. If you want to take a picture of this, go ahead and grab those phones real quick, because I ain't trying to write all that. Okay? I ain't trying to write, at least not right now, right? At least not right now. Okay? I don't have a phone, so I have to write it down. And again, anything that falls outside of those fences would be considered an outlier. Anybody want me to pose? Nah, take a picture of that, not me. I should be on the side somewhere.
He's just like,
I'll have to get all kinds of hats. Yeah, you just wanted so you could put me on the Snapchat, huh?
how about you?
Sorry, I just remembered the Tingle Bling hotline. You seen that? Oh, you gotta see it, dude. I was dead. It's short, but it's funny. Did you see it at least already? No, what? Are you serious? You saw it?
No, don't show me.
Shut up. It's not funny when nobody else knows what you're talking about. Right?
Show it.
I show you. I showed it to another class. I'm like, wait a minute, maybe I shouldn't have showed that. That's not good. It's funny though. Your discretion is advised. Is there really Gatorade in that?
It's water.
I'm just saying because you're kind of false advertising there.
It's water.
That's fine. I mean, if you have Gatorade, I'm just like, Gatorade bottle must have Gatorade.
No, yeah, I know. It's water.
It's just water with food coloring. Cold water?
Yeah, it's pretty cool.
Are we good here? Can I move on?
Yeah.
All right, thank you. This is just some kind of silly. You know how the rule is the 1.5 times the IQR? So they asked John Tukey, which is the guy who did that rule. They say, hey, John Tukey, why did you choose 1.5 IQR? And he said, well, 1 seemed like it was too little and 2 seemed like too much. So I went with 1.5. Not that Tukey. Isn't that the guy's name too? The one that made the Crips? It was like Tukey something? Never mind. Well, I'll look it up right now. Okay, so cool. Another thing, you know how we talked about the minimum, the quartile 1, the median, the quartile 3, and the max? Those 5 numbers? Those bad boys are also called the 5-number summary. So if you want to describe a distribution, not saying, oh, the center, unique feature, shape, and spread, you can also talk about the distribution with the 5-number summary. So I'm talking about the min, quartile 1, median, quartile 3, and the max. Okay? Someone nod something?
Yeah.
It look like the pot people out there. Yeah, so here's your 5-number summary. You guys already know what it is. It's just another name for it. But if you want to describe that distribution because you know that it has some outliers in there, you might want to use this. Okay? Because then the person can also automatically right away grab your interquartile range, take quartile 3 and subtract from that quartile 1 right away. This was just the box plots, the way they really looked for Hank Aaron's and Barry Bonds. And obviously, I mean, they're really close, aren't they? Except one whisker is really long over here because of that 73. Here's a question, because of those steroids. That was good too. Which one of these, take a look at Barry Bonds up here. Okay? Now, here's where your analysis comes in. Here's where your common sense comes in. Ready for this, Ariel? Because I'm going to ask you probably. Everybody ready? Because I might not ask her. Which one of these quartiles has more data in it? Which one of these quartiles for Barry Bonds has the most data in it? Okay, I know that you know it's a trick question because you're looking at me kind of funny. But the question still stands. Which of those quartiles, there's 4 of them, which of those quartiles has the most data in it? Ariel. Is it quartile 1, quartile 2, 3, or quartile 4? Which of those quartiles has more data in it? Thank you for playing the game. Not exactly correct. CFAT.
What did she say?
She said 4.
I say 3.
You say 3? 3 has more data in it? 2? 2?
Don't they all have the same?
Thank you! Say it nice and loud one more time.
They all have the same.
They all have the same amount of data. It was a trick question. I said it from the beginning. Right? How did we do this? We took all the data, and then we found the middle of them, and the middle went right there, didn't it? That means there was half the numbers on this side, and half the numbers on that side. Right? And then we cut that half in half, which is why it was called a quarter. Nice job. You impressed me.
She asked her.
Let me see the other ear. JK. JK, LOL, smiley face. Alright, good job. So yeah, and so notice this jump between this one and this one. I mean, if you look at that, that looks impressive. But here's what it really looks like. So what you would have to create is this thing called a modified box plot. So the top that you're looking at is a modified box plot. Whoa, that's it? Homework tonight. 5 number summaries on those bad boys. 5 number summaries on the 10 problems. The ones that the data I gave you. 5 number summaries, please. Minimum, quartile 1, median, quartile 3, max. Yeah, those 5 numbers, right?
What did you mean by what we have to describe it? Like if it was a
Center, unique feature, shape, and spread. So where does the middle look like it's at? What was the shape of it type thing? You'll get it back. You'll get it back. You want to make sure you get full credit right now.
I want to do it real quick. Because I didn't describe it.
Okay, that's fine. If it's incomplete, I'll give it back to you as incomplete. I'll give you more time to do it, but you still get your full points back. So leave it that way for now.
What do you have to do with this?
Take it. I know. I saw you that you did it. Yeah. Yeah. For yesterday, yes. No, you'll get it back from me.
Mr. Munoz, do I have to stay at school to do